Hi, today I'm going to be talking to you about protein and how protein is used in the body of the cow, and we're going to learn together about how we can understand the forages that we are harvesting and how they're used within the animal's body, and in that way it'll take us a little bit closer to some of the efficiency things that we're trying to get to. We know that both protein and energy are needed together to achieve proper function in the rumen, but today, for this discussion, I'm going to separate the two categories of nutrients and just look at protein. We know, yes, we have to be balanced, we know that. Balance is a key, and what we're trying to do is get the rumen to optimize its products, and the product of the rumen from a protein standpoint is microbial crude protein. So when in balance, microbial protein is produced with a similar amino acid pattern to milk and lean tissue. For the beef cow, what we're looking at is to produce lean tissue, to produce a calf that will grow really well, and to maintain that cow. So when we're using a ration balancing program, all of the things that I'm going to talk about today are going to be included in that program, and it's going to take that into account once we put in our feed test results. It's most common for us to be talking about crude protein in a lot of the meetings that we have, but to really understand the true nutritional contribution of protein to the diet, it's very helpful to break it down into its components and then to see, well, how is this actually used in the body of the cow? I'm going to talk about that today. Then we're going to take a look at some of the common grains and forages that we use and how they contribute protein and in what form it is, because not all forages are created equal. So let's start with some definitions of the various components that I'm going to be talking about. Protein is consumed by the cow. From that point, it becomes rumen degradable protein, RDP. Sometimes you'll hear it called digestible intake protein, degradable intake protein. Then we're going to talk about rumen undegradable protein, or undegradable intake protein, but for today's discussion I'm going to use RDP and RUP. I'm going to talk a little bit about microbial crude protein, and then finally metabolizable protein. I'm going to explain all those terms, and hopefully that's going to help us get to where we need to be in terms of more efficient feeding of our animals. So rumen degradable protein, RDP, that's the portion of the protein that is degraded into free nitrogen in the rumen for the microorganisms to manufacture high quality protein. So following that, we understand that some of it is not degraded in there. So we refer to that as rumen undegradable protein. The undegradable portion just simply means that the microorganisms can't break it down in the form that it is in that forage or grain. And so a portion of that passes into the stomach and then small intestine for digestion and absorption. The stomach I'm referring to is the abomasum, the true stomach, where all the contents of the rumen emptying into that are subject to acid hydrolysis and then subsequent digestion and absorption in the small intestine. So the next term I want to talk about is microbial crude protein. This is a very high quality protein. It comes from the bodies of the rumen microbes. Some of those microbes can have a lifespan of 20 minutes and some up to 8 hours. So we see that, wow, if we supply sufficient nitrogen and sufficient energy in the rumen, that we can optimize the production of rumen microbes and thereby optimize microbial crude protein. That type of protein, being such high quality, can supply 50 to 60% of the total needs of the animal. So it's really important in terms of producing milk in particular, and in some cases the total production of rumen microbes, that microbial crude protein, we don't need to supplement the animal at all when it's in early gestation. So pretty important that we optimize it. We can't maximize it because the beef industry, being a fairly low margin industry, means that we have to be conscious of how much it's costing us to generate the kind of results we want to get. So metabolizable protein is true protein, and it is composed of the undegradable portion coming out of the rumen and then the microbial crude protein added to it. So that becomes the total supply of protein for that animal. Crude protein is a term that we use most frequently because we get it in our feed test results. And crude protein supplies nitrogen for us. But the problem with the term crude protein is it doesn't really tell us anything about RDP or RUP, the degradable and undegradable portion, and what is actually available for resynthesizing into microbial crude protein. What's available for those microbes? And so that's why the next term, metabolizable protein, was introduced. And metabolizable protein is the total amount of protein that would be supplied by the microbes plus the undegraded protein and is available for production in the animal. Generally, the first 6 months of gestation, additional crude protein really isn't needed if the pasture is strong. The last 3 months and also the start of lactation, it's really probably necessary to be supplementing crude protein. Also, as pasture gets older in the year, in the grazing season, crude protein tends to drop fairly quickly and the degree of lignin in a plant starts to rise. So the other consideration in terms of the cycle of production for the cow is once she's finished pasture in the fall, we may have some crop residue to graze, or we may have some stockpile grazing planned for the herd, and we should recognize that that stockpiled forage is going to deteriorate through the year. So we have to understand that, okay, it might start out at 7 or 8% crude protein in the fall, but as it weathers and goes into late October, November, and early December, it may drop as low as 2 or 3% in crude protein. So understanding that, we're prepared to step in and do some supplementing. So what are we going to supplement, and how is it going to be able to be utilized by that cow? So what I've done is put together a little bit of a chart here, and on the chart what you're going to be able to see is some of the common grains we use, some of the common silages, and then hay, straw, and right at the bottom you're going to have some DDGs, distillers dried grains with cellulose. And so you can see in the columns there, the crude protein doesn't really indicate necessarily what RDP and RUP are going to be. And so as we look through, we can see that the barley and oats are fairly well balanced, but corn, still being a grain, has a fairly low RDP and a fairly high RUP. And so take that into consideration. If we look at corn silage, it's the reverse of corn. So it looks like they might be a pretty good match, and they are to a degree. But once we get into high production situations, then we have to understand the limit of the rumen doesn't allow us to feed that animal as much protein as it needs from those two products. So we need to be considering protein source from something else, and DDGs often matches up very well with that, not only from supplying degradable protein, undegradable protein, but also from a cost standpoint. So these are the ones that we generally have. The point I'd like to make to you is that it's really important to consider rumen degradable and rumen undegradable protein and what is actually going into the animal compared to what it needs. Ultimately, we want to produce through the diet ingredients sufficient metabolizable protein to meet the animal's requirements, whether it's for maintenance or whether it's for production. A good ration balancing program will do that for you. And at Highline, we are very conscious of these kind of things. We design our equipment and add little bits of technology to it so that whatever the requirement of the ration is, we can supply it through our machines. Thanks very much. If you have any questions, I'm happy to answer them.